This question says, consider the following elementary reaction. We have H2O2 plus I minus reacting to form water and IO minus. It says, suppose we let K1 stand for the rate constant of this reaction and K minus 1 stand for the rate constant of the reverse reaction. Write an expression that gives the equilibrium concentration of IO minus. So here we have an elementary reaction, and we want to write the rate of the forward reaction, the reaction as written, is equal to K1 times concentration of H2O2, concentration of I minus. For the reverse reaction, the reaction going in this direction, again it's an elementary reaction, we just consider these as the reactants. So the rate equals, they told us to use K minus 1 for the rate constant, concentration of H2O, concentration of IO minus. So now we have these two rate expressions. But the key thing we have to realize here is that this reaction is at equilibrium. At equilibrium, the rate of the forward reaction and the rate of the reverse reaction are equal. In fact, that's what equilibrium means. The rate of the forward and the rate of the reverse reaction are the same. So this rate equals this rate. Said another way, this expression equals this expression because the rates are the same. All these things are equal would be another way of saying that. So K1, concentration of H2O2, concentration I minus, equals K minus 1, concentration of H2O, concentration of IO minus. Now it asks for us to solve in terms of IO minus, so we divide by K minus 1, concentration of H2O, and what we end up with is the concentration of IO minus equals K1, concentration H2O2, concentration I minus, divided by K minus 1, minus 1, concentration of H2O. So this, I apologize, I didn't have that on the screen. So basically I just divided by H2O, and then I divided this side, or by K minus H2O, and then I divided this side by K minus H2O, and I ended up with this expression. One important thing to note, that if you're actually writing the equilibrium constant, which we will do in later chapters, you would probably ignore H2O because it's a liquid. And essentially one way to think about this is the concentration of a liquid is essentially a constant, and therefore it's not included in the equilibrium constant expression. Note that this is not written as an equilibrium constant expression. It's written in terms of concentration of IO minus, but it could be changed into one, which you will see later on in the course.